Linear approximations. Suppose you wanted to evaluate a complicated function near a point x equals a. For example, suppose you wanted to evaluate the function f of x equals the square root of x near x equals 25. We can find the equation of the tangent line at x equals 25 and then use this linear function, which we'll call t of x sub 25 equals mx plus b, to approximate f of x equals the square root of x when x is near 25. I know this sounds a little complicated. Let's look at an example. Suppose we wanted to approximate f of x equals the cube root of x at x equals 26. In other words, we wanted to find the cube root of 26. So what would we do? Well, step one. First thing, we'd look at the derivative of f of x, which is 1 over 2x to the 2/3 power, and we see that it's easy to evaluate this function at x equals 27, and 27 is near 26. So we'll find the equation of the tangent line for f of x at x equals 27. We'll call this tangent line t of x sub 27. So we'll find the equation of the tangent line at a nice easy point near the point of interest, 26. And we have a point already, right, in the function. We have 27 where we're finding the tangent line and function of 27, which is 27 and 3. Very easy to find, right? And we have a slope at x equals 27, which is 1 over 27 for the function of x at x equals 27. So we have a point and a slope. Once we have a point and a slope, we can use we can find the equation of the line, tangent line in this case, by using the point-slope formula from elementary algebra, y equals m times x minus x1 plus y1, where m we know and x1 we know, it's from our point, and y1 we know from our point. And when we do this, here's what happens. We just plug in the numbers, right? We know the slope is at that point, and the graph is 1 over 27. We put 27 in for x1 plus 3 in for y1, and we do a bunch of simplification, and we get y equals x over 27 plus 2, or we say that t of x is x over 27 plus 2, where this 27 indicates where we found the x value for which we found the tangent line. Okay. We say that the cube root of 26 is function of 26, because function of x is the cube root of x. But it's also approximately the tangent line we found at 27 evaluated at 26, which when we simplify we get 80 over 27 right here. Okay, 80 over 27. Now I popped that into a calculator into 5 digits and got 2.9630, but 80 over 27 is the exact answer. So this is our approximation for the cube root of 26. It is interesting to note that the calculator approximation of the cube root of 26 to 5 digits is 2.9625, and the calculator approximation of 80/27 is 2.9630. They're very close. So we came very close to our original target of the cube root of 26, and we evaluated it in a line, not in a cube root function, notice. Here's a picture of what we did. This is a kind of a crude picture, but I think it shows it. On this curved line here, this is the right side, or the positive side, of the cube root of x. And then we found our tangent line right here at 27. And then rather than plugging this 26 into the function, we plugged it into the tangent line. Notice our tangent line is not quite right on the curve, but it's a little higher than the curve is, and a little bit higher, and that's really true here. We got 2.9630, and it was 2.9625 for the real answer. So the error is going to be, we're going to end up with more than, it's going to be a positive error, in other words.